Let's go ahead and start. I'm hoping that you learned something along the lines of, please excuse my dear Aunt Sally,
I don't use that.
or gems. Have your elementary school teachers or whoever you learned in junior high, did they use PEMDAS or GEMS to tell you order of operations?
Yes.
Order of operations. Groups, exponents, multiplication, division, and addition, subtraction. That's what I believe GEM stands for.
Yep.
If you've never heard of PEMDAS, please excuse my dear Aunt Sally. That's the way that people used to remember it when I was young. They used parentheses, exponents, multiplication, division, addition, subtraction. Same thing. What you're supposed to do from left to right. So, the most common mistake that I've seen are that some students forget why we're doing the distributive property. So let's start with an example. Here's example number 1. Example number 1 is a very simple problem. I'm going to throw in a couple things here just to review some concepts with you. I have 3, I have parenthesis, and I have 2 minus 5 inside the parenthesis. If you're doing the order of operations, if you are following either PEMDAS or GEMS, you should know what you're supposed to do first. What am I supposed to do first here? I'm supposed to do the group or the parentheses. What that means is there something inside the parentheses that you can do? Can you put 2 minus 5 together? Can you do 2 take away 5? What is 2 take away 5? 2 minus 5 is negative 3. So we do this group first, or we do the parentheses first. We're doing what's inside parentheses first if we can. And then there's no exponents. There's only multiplication left. How do I know it's multiplication? Whenever I see something outside of parentheses, I need to think of multiplication. I'm going to write that off to the side. Parentheses, I'm going to just draw it out, means multiply. Whenever you see parentheses, it means you're going to multiply what's inside there with whatever's outside of the parentheses. It doesn't mean that I multiply what's inside. I had to do what was inside, 2 minus 5. But parentheses means that I'm going to multiply the 3 times the negative 3. What is 3 times negative 3? And that's what our simple answer is here. The reason why I started with this particular problem is because some of you will want to distribute. You see parentheses and you say, oh, I'm going to distribute. Nope, nope, nope. You don't need to. Distributive property isn't meant to distribute over parentheses all the time. If you can put things together, put them together. But then there was a problem that they couldn't do. Example number 2. Seven, parenthesis, z minus 4. If I'm following order of operations, 7 parentheses z minus 4, I have to try to do parentheses first, z minus 4. And I'm not sure if you know this, but if I'm trying to take away 4 from something that I don't know what it is, I'm trying to take away 4 from some amount that I'm not sure how much that amount is. This is an unknown. And I'm trying to take away 4 from it. You can't put those together. You cannot simplify it. It is not, somebody told me, it's not negative 4z. That's not the same thing. Okay? The distributive property was made for this type of problem. So one little side note that I need to add here is the word like terms. Like terms. Let's underline like terms when we write it, because it's kind of a definition. Like terms have the same variable. And I'll put in parentheses S, variables. They either have the same variable or variables. There can be more than one. And this is important to us because we can only add or subtract like terms. Like terms have the same variable or variables, and we can only add or subtract like terms. So let's look at this, and let's go back to example 2. I have a z, I have a minus 4. Are these like terms? Does this 4 have a z in it? Does this? No, it doesn't. That means I cannot add or subtract these. That means I cannot put these two things together. I am unable to put these together in the gems in the order of operations. So what we have to do is we have to use something called the distributive property. And I want you to think of the distributive property as something like the donut principle. Here's my donut principle. If I have a donut or even a box of donuts, and I were to have a box of donuts, and I make the decision that I'm going to give a donut to this kid, this kid, this kid, this kid, this kid, this kid, and I give donuts to everybody on this side of the room. What are you guys going to think over here?
I don't like you anymore.
I appreciate your honesty. You guys will be upset, mad, feel bad. The donut principle. The donut principle says if somebody has donuts and they give them out, you want one, usually. Unless you're really good at controlling your appetite. Me, I'm not so good.
Same.
Okay. So, if I distribute something, I don't just distribute it to the first term. I have to distribute it to every term inside the parentheses. That's what the distributive property is. It's very much like donuts. If I do this 7 and I multiply it to the z, I have to also make sure that I give everybody inside this room the same donuts. If I do 7 times z, I have to also multiply 7 times the negative 4. That is the distributive property. And parentheses means multiply. So I'm going to multiply 7 times z. 7 times z is? 7 times minus 4 is? And can I put the 7z together with the negative 28? Are these like terms?
No.
No. So this is as far as we can get with example number 2. This is why I wanted to tell you the term like terms. You can only combine like terms when you're doing problems like that. And that just basically goes to show what the distributive property is. I'm going to write down over here distributive property. What is the distributive property? That's how I'm going to try to answer that question for you. Let me move that up a little bit. We're going to multiply over parentheses when we have unlike terms. That's what the distributive property is. If you want to, little side note, like donuts. Maybe you'll remember that. And you can put that in either, and it says questions over here. You don't have to put questions there, but we can go back to this and go, oh yeah, I remember he was like the donuts. You have to do it to everyone inside that group. Keep it fair. This works whether the group is in front or whether the group is in back. This is multiplying. In example 2, the z minus 4 is in the group, and I have 7 times the group. But we could also have the group times the 7, and the 7 could be in back of the problem. So let's do another example. We'll call example 3. What if the group was in front and there was a 5 in back? Don't forget that multiplication is the same no matter which direction it is. For example, 2 times 3, is that the same thing as 3 times 2? Are those the same thing? Yeah. They are the same. 3 times 2 is the same as 2 times 3. That's because multiplication is commutative. You can move it. I can move the 5 in front or the 5 in back. It doesn't matter because I have this group multiplying the 5. It is multiplying. So that means this group is multiplying 5. And can I put the 6y and the 3 together? Are those like terms? No. There's no y's in this one. I can't put it together with the 6y unless there's 3 y's there or something. So what can I do? I can distribute the 5 into this term and into that term. Terms are always separated by plus signs and minus signs. I'm going to write that off to the side over here. Terms are always separated by plus signs and minus signs. Terms are always separated by plus signs and minus signs. So here's a term, 6y. It's a positive 6y. That's one term. And then the 3 is another term, or a negative 3 is the second term. There's 2 terms inside this one. And if I were to distribute the 5, it would be? Tell me what the next one is. And my next question, can you put the 30y and the 15 together?
No.
Nope. Because they're not like terms. Wonderful. You almost have everything I want you to have. But what happens if there's a negative? Over here I'm going to put example 4. What happens if there's a negative p minus 6. What if I have a negative in front of a parenthesis with a p minus 6? Let's see what you remember. Jada. So you can pretend that there's a negative 1. Here's what I do. If you want to do it, you're welcome to. I put my negatives, I put a little dotted 1 because there's an invisible 1 behind that negative. Shh, quiet down, please. And since this negative 1 is in front of the parentheses, I still have to multiply by negative 1. I have to distribute that to the p and to the negative 6. Let's see what you remember. Negative 1 times p would be what? Say it out loud.
Negative p.
If you said negative 1p, that's fine. Will I write the 1? No, because I like it more simplified. Simplified means smaller. Not writing that 1 makes it smaller for me, even though there is an invisible 1 here. Then I have a negative 1 times the negative 6, which is what?
Positive 6.
Can I put these two things together? So this is my final answer. Textbooks and SATs and SBAC questions will change this to this, 6 minus p. I don't care if you do. I prefer the first answer. Chase? Why did I put the dotted 1 there?
No, under the negative.
Under the negative. That was just like a mess up. It's supposed to just be a negative dotted 1. That's it. Textbooks and SBAC questions will write their answers like this, 6 minus p. And literally, it's because they are trying to save ink. There's 1, 2, 3, 4 things if you write it this way. There's 1, 2, 3 things if you write it this way. So sometimes they will save themselves a little bit of ink and write it this way, and it's more simplified to them. But I don't care. This is the same thing as that. Okay. Next level. Example 5. I have 2 more examples, and then we'll be done with this, and you'll get to start your worksheet. Example 5. 2x plus 3 all over 3. 2x plus 3 all over a fraction of 3. I know this looks weird, but I want you to see one extra step. This may not look like the distributive property, but it is. If your junior high teacher never taught you this, I want you to know. Rachel, Mark. If your junior high teacher never taught you this, this 2x plus 3, since there's a bar that goes from here all the way to here, what that means is this. That means the 2x plus 3 is actually in parentheses. That bar going all the way across means that that is a group over 3. 2x plus 3, put that in parentheses over 3 just like that. And then what we're going to do is we're going to move this divided by 3, and I'm going to keep it divided by 3, but I'm going to show you a little trick because it's still the same thing. Here's the 2x plus 3 in parentheses, and I'm going to move this divided by 3, and I'm going to put it like this. I'm going to move that 3 to there, and I'm going to move the invisible 1 that's not there to right there. And now I can use the distributive property. And I can do 1/3 times the 2x, which is, do you know what that is? If you're not sure, this is what we're doing with the fraction times the 2x. It's 2x over an invisible 1. The 1 is multiplying the 2x. That's your numerator. 2x. The 3 is multiplying the invisible 1, which is over 3. 2x over 3 is the first thing, but don't forget your donuts. You can't just distribute to this half of the room. Got to go to the other half of the room. And speaking of that, if you feel like bringing donuts for your classmates, feel free to do so. I will partake, of course.
January 23rd on a Monday.
Don't forget, your birthday, bring them. It'll be great.
It's on a Monday. My birthday's on a Monday. What? Yeah, you are. Yeah, you are. The start is in the morning. No, you're just bringing it for me.
Class.
Yes.
There we go. And if I distribute the 1/3 to the 3 will be on top, and there will be a 3 on bottom. And does that reduce? Does 3 divided by 3, does that simplify? Yes. What does it simplify to? 1. Good. You are correct. And my final answer for example 5 should be 2x plus, or 2x over 3 plus 1. I'm not sure if you understood what we just did there, but I'm hoping it makes sense to you. If you understood what I did there, then I want you to try this one, compare it with your neighbor, and see if you come up with the same one. 5t minus 2 over 10. 5t minus 2 over 10. Try it using the same technique, and I'll do the first step with you so you can make sure you're doing the first step right. 5t minus 2. And then I'm putting in front 1/10. I'm hoping you know what to do from there. Make sure that you are putting it in lowest terms. Speaking of that, now is a good time for me to show you a button on that calculator I recommended that you buy. If you are not good with reducing fractions, the calculators that we have in the back of the class, here's an example, have this button called a fraction button on them. And the fraction button on them looks just like this that I'm pointing to. It has a box over a box. If I press it, what ends up showing up on my screen is a box, fraction over a box. And it's basically saying, what do you want to put on top of the fraction? Let's put the 5. And what do I want on the bottom of the fraction? I can't put the t in there, but I can put the 10. And it will reduce this into lowest terms. Let me press equals and look at what the calculator knows to do. It knows to put it into lowest terms when you press equals. Kind of cool. So this is 1 over 2t, otherwise known as t over 2. I could do the same thing with 2 over 10. If I'm not good with fractions, 2 over 10. And it will divide by 2, and it will put minus 1/5. My final answer should be t over 2 minus 1/5. How many of you got t minus 2 minus 1/5? I'm just curious. Wonderful.